Hi and welcome to today's class. Good morning. In the last class, I made you do a couple of problems from Mirodov because those questions were doable and those questions were easy. Most importantly, I wanted you to realize that you can solve questions from Mirodov. People think it's a difficult book. I don't think so. You can solve these questions. It's pretty easy. Today's class is just taking problem solving to another level. I'll try to show you more problems, but from HCV. Okay, you should try getting an HCV and you should try practicing the problems in it. Quite probably, most of you people will have the problems, the book already with you, so it shouldn't be a problem. Okay, let's begin. First of all, we'll go through a couple of solved examples from the book. Okay, that should set the scene, and then we can start solving more problems. On page 184, look at question number 4. Page 184, this is part 1. Look at question number 4. It says that there is a string wrapped around the rim of a wheel. So there is a wheel and the wheel is fixed to the ground. So this band, it says that the wheel is fixed to the ground. So the wheel cannot move horizontally. And there is a string that is fixed to the wheel. Okay. And the force is acting in the horizontal direction. The moment of inertia of the wheel is given as 0.20 kg meter square. The radius of the wheel is 20 centimeters. So that is 0.2 meters kg meter square. Okay. And you're applying a force of 20 newtons. The force over here is 20 newtons. So it's asking you find the angular velocity of the wheel after 5 seconds. So given all of this information, if you find out alpha, then you can write change in angular velocity divided by time is equal to alpha, which means that change in angular velocity is equal to alpha delta t because alpha is going to be constant over here. How do I know alpha is constant? Because the force over here is a constant, r over here is a constant. Therefore, combining both of these, the torque is constant. So because the torque is constant, the alpha value should also be constant. Delta omega means omega final minus omega initial. So this is equal to alpha delta t, which means that omega final is equal to omega initial plus alpha delta t. Okay? Omega final is equal to omega initial plus alpha delta t. The plan of solving this question is to find out alpha. The wheel, I think, starts from rest. The string is now pulled. Okay, so initially the wheel is at rest. So omega I is equal to 0. So when you pull the string, you're going to have rotational motion of this disk. And as a result of that, there will be angular acceleration and the speed is going to increase. The time given to you is 5 seconds. So delta t is equal to 5. अल्फा कैसे निकालेंगे? अल्फा इज इक्वल टू टॉर्क बाय मोमेंट ऑफ इनर्शिया. Alpha is equal to torque divided by moment of inertia. So what is the torque over here? Torque is equal to R into F. So R is equal to 0.2. This is your R value from the axis to the edge. This is your value of R. And the value of F is 20. So 0.2 into 20, that is 2 times 2 is 4, divided by the moment of inertia is equal to 0.2. So that means that the angular acceleration is equal to 20 radian per second square. So you put that value of 20 over here and the time is equal to 5, which means that the angular velocity is equal to 100 radians per second. Okay, fairly easy. It's a very easy first question for you to solve. You can easily solve it. So I hope you understand how we frame a question and how we try to solve the question. Another one. Question number 5. There is a plane, frictionless plane, and there is a mass kept on it. And this mass is attached to a string which is attached to a pulley. So it says that a wheel of radius r and moment of inertia I. So its radius is r, the moment of inertia is I, and it is attached to a mass of m. A string is wrapped around the wheel and its free end supports a block of mass m. Initially, the wheel is rotating at a speed omega. So that's the further thing in the question. The wheel is initially rotating at a speed of omega. That's the initial value, omega initial. Okay. So it's asking you how far up the incline will the block move. So let us say the block will move up by a distance of x. So you need to find out x. So what is the distance the block will travel before it comes to rest? Okay. So because this wheel is rotating at a speed of omega, you know that jitna ye wheel rotate hoga, basically L is equal to r theta. The amount something is going to rotate, the same amount the string is going to get pulled. We have always written A is equal to r alpha. So in the same way, we can write V is equal to r omega. The amount the wheel is rotating, the same speed the block is going to move up the incline. This block is going to start moving with a velocity v, where v is equal to r into omega. The velocity of the block and the rotation of the wheel, they are related to each other. So that is the first relation that we have, that v is equal to r omega. It is going to stop. So whenever it is going to stop or its speed is going to change, we can use our formula v square minus u square is equal to 2 into a into s. It is going to stop, which means that its final speed is equal to 0. Its initial speed was equal to v, so 0 square minus v square is equal to 2 into a into x, because the distance traveled by the block is equal to x. So we need to calculate x as minus v square divided by 2 into a. So basically our plan is to find the value of a. The goal of our question is to find the value of acceleration. How do you find out acceleration? Now this block is going to move in the upward direction. Okay, the block is going to move in the upward direction. So let us draw all the forces on the block. The forces on the block are T in the upward direction, mg sine theta. How? So let us say this angle is equal to theta. The weight acting on this weight is equal to mg. You can split this mg into two components where this angle is equal to theta. So this component is equal to mg cos theta and the other component is equal to mg sine theta. Okay, so that is t, and in the downward direction you will have mg sine theta. समझ में आया? Now for the wheel over here, the wheel is going to rotate in this direction, whereas the torque is acting in the reverse direction. This is the direction which the tension is acting in the reverse direction. Okay, so this is moving in the upward direction. We will say the acceleration is in this direction. This is rotating like this, so we will say alpha is in the same direction, and we will write A is equal to R into alpha. The linear motion is related to the rotational motion as A is equal to R alpha. Now let's write out the equation. So you'll write plus T minus mg sine theta is equal to m into A, first equation. And then over here, the torque is acting opposite. If you think of a steering wheel, the torque is acting opposite. So we cannot write plus, we'll write minus R into T is equal to I into alpha. ठीक है, तो T का वैल्यू कितना होगा? T का वैल्यू हो जाएगा minus I alpha divided by R. So what is the value of alpha? The value of alpha is equal to A divided by R. So that will also become IA divided by R square. Put this in the first equation. So if you put it in the first equation, you will get minus IA by R square. Okay? You will get minus IA divided by R square minus mg sine theta is equal to MA. So you can move this to the right side. You will get A into M plus I divided by R square is equal to minus mg sine theta, which basically means that the value of A is equal to कितना हो जाएगा? mg sine theta divided by m plus I by R square, but with a minus sign. So A is equal to minus mg sine theta divided by m plus I by R square. Now you take this value I divided by R square. Okay, I cannot write the 2 over here somehow, R square. So you take this value of A and you put it in the equation where we wanted it. So over here, instead of A, you can now write कितना हो जाएगा? Minus V square divided by 2 times acceleration, which is again minus mg sine theta divided by m plus I by R square. So into m plus I divided by R square. So the minus and the minus is going to cancel. So you're going to end up with this equation over here, which is equal to V square, okay, V square into m plus I divided by R square divided by 2 into mg sine theta. So 2 mg sine theta. Now remember that V was never given to us in the question. We were actually given omega. So instead of V, we need to write R omega because we were given omega in the question. So we will write R omega. So this will become R square omega square. So you keep R square, you keep omega square outside. You multiply the entire thing with R square. So instead of M, you will get MR square, and instead of I by R square, you will get I. So it will become MR square, and instead of I by R square, you will simply get I. So this thing over here is the distance that the block will travel. Omega square into mr square plus I divided by 2 mg sine theta. So what did we do? First of all, we tried to write down an equation for what is required. What was required is x. So we wrote down an equation that involves x in it. We saw that this thing depends on acceleration a, and then we started solving like I've taught you in previous classes how to solve. We started solving and we wanted to find out what is the acceleration of the block. So after finding out the acceleration, we just simply applied v square minus u square is equal to 2as. Okay, and that solves the question. Pretty straightforward. So this is question number 5 from that book. Okay, so let's try another one. Question number 6. All of these questions have been chosen with one thing in mind. These are all applications of tau is equal to I alpha. So tau is equal to I alpha. I want to teach you how to apply this equation. Keep in mind, in this equation on the left side, the torque represents the net torque of all the forces acting on a body. The right I, that is the moment of inertia of that object, and alpha is the angular acceleration. So how you do this is that you choose an axis, you find out the torque, and then you write tau is equal to I alpha. In questions like the last one, the axis of rotation is already well defined. The center of the pulley is the axis of rotation. So this is directly R. Okay. So you don't have to choose an axis of rotation in most rotational problems. But if the situation is in rotational equilibrium, if you remember, whatever axis you choose is going to work out fine. It is suggested that you choose the center of mass as the axis. Okay, center of mass choose karoge to axis, the problem can be solved like pretty nicely. Try it and let me know. Center of mass ko hamesha choose karo as the axis. So okay, let's start with question number 6. Question number 6 says that there are two blocks and there is a pulley, but except this pulley now has a mass to it. So there is a pulley. इसका moment of inertia I है, radius is r. This band says that this pulley cannot move. So this is I. The radius of the pulley is equal to r. And on both sides, there is a rope. And this, the mass is m. And that mass is capital M. This problem is going to teach you something new. Because so far, we haven't ever dealt with a problem where there are two masses or there is a string that is passing over a pulley. The first thing you should understand over here is that in a string, normally we say the tension on both sides is the same. But in the case of rotational motion, the tension in a string on both sides of a pulley, the tension is not the same. Okay? The tension on both sides of a pulley is not the same. The tension on both sides of a pulley with mass, is not the same. So first thing, it is not T. Instead, it is T1 and T2. Okay. And now you can start drawing the free body diagram for this entire problem, and then you can start solving. But you might ask me, why is the tension different? Why is the tension T1 and T2 different? The answer for that is because of friction over here. Over wherever this rope is in contact with the pulley, kind of like the chain of your cycle or your bike, the rope is going to attach to the pulley and then it is going to rotate. So in a chain of a bike, there is a special projection that's called as the sprocket of the bike, the back thing. There the chain actually locks because in a bike the torque is very high. In books we don't draw that, but we are relying on the friction between the rope and the pulley to rotate the pulley. So because of friction, you must have seen in your cycle chain also, the top part of the chain is kind of tight, the lower part of the chain is kind of loose. So tension on both sides of the chain, both parts of the chain is not the same. That's because of friction at the pulley. Same reason है यहाँ पे. तो T1 T2 हो जाएगा. Now you try to draw the free body diagrams. तो ये तुम्हारा pulley है. This is T1. that is T2. This is your block over here. The mass of the block is equal to M. So this one is equal to T1, that one is equal to mg, and that is your smaller block, small m. तो इसका ऊपर की तरफ T2 and नीचे की तरफ mg. Now you have solved many motion problems, so I don't need to teach you how to do this. We'll solve it in easy way. We'll just say that, let us say this goes up and let us say that thing goes down. The first thing to do in the problem, everywhere you mark the direction of motion. So this is alpha, this block is going to go up and that block is going to come down, and a is equal to r alpha. Basically जितना ये block move करेगा उतना वो pulley rotate करेगा. The pulley rotates by the same amount that the block moves. Okay, so it's a very plain and straightforward thing. A is equal to r alpha. अब हमें इसको solve करना है. So the first thing you'll do is you'll write equation, like you drew an FBD. That's the first thing. The second thing you'll do is you'll write out the equations now. So you'll write plus mg, ठीक है, minus t is equal to ma. How? Because the direction of the force is the same as the direction of the acceleration. So plus mg minus t is equal to ma. So this t is t1. For the second block, you will write plus t2 minus mg is equal to small m into a. So plus t2, because the direction is the same, minus mg is equal to small ma. Now for the pulley, keep in mind that T1 is matching the direction of acceleration and T2 is opposite to the direction of acceleration. So the torque of T1 is positive, the torque of T2 is negative. So you will write plus RT1 minus RT2. Plus RT1 minus RT2 is equal to I into alpha. Is equal to I into alpha. So what is the question asking you? Find the magnitude of acceleration of the two blocks. You want to find out the value of A. So to find out the value of A, what we will do is we can either find out the tensions T1 and T2, or the better thing to do over here is we can just replace the value of alpha. So you remove alpha from here and you put in the actual value of alpha from this equation. So alpha is equal to A by R. So instead of alpha, you write A divided by R. Okay. Now, instead of T1 and instead of T2, try to find out the values of T1 and T2 from these equations and you try to put it from there into this equation. So what will you get? You'll get plus R multiplied by T1. So what is T1? mg minus ma. So mg minus ma minus R T2. So minus R T2 is equal to ma plus mg is equal to Ia divided by R. So right now you can cancel the entire equation. You can divide the entire equation by r. तुम यहाँ से r हटा दो, r यहाँ से हटा दो, and over there you can just write Ia divided by r square. Solve. ठीक है, इसके आगे क्या करना है? Solve करना है. mg minus ma can go to that side, so it will become plus ma. Then you will have minus mg. Again minus ma can go to that side, it will become plus ma, and you will have Ia divided by r square. So finally, taking a common, you will have m minus m into g divided by m plus m plus I divided by r square. समझ में आया? So that's a pretty simple and straightforward thing. You don't have to do much. Just write down, just see what's happening. The new thing over here is that in case of rotational motion, जब भी कोई चीज like there is a rope passing over a pulley, the tension on both sides of the rope is not going to be the same. On one side of the rope, the tension is going to be a little higher. On the other side of the rope, the tension is going to be a little lower. But you have no way to find out, like, कि कितना tension किस तरफ है. So you just take it as T1 and T2. Assume a direction of acceleration. Just go ahead and solve the problem. Pretty simple. ठीक है. तो इसके आगे क्या करना है? We'll do some more problems. Go to the exercises and we'll start with question number 33 from there. We'll start with question number 33 from the exercises. 33, 34, 35, 36, 37, all of these questions, even 38, all of these questions, they are very similar in that there is a pulley, there is a block, and there are one or two things that are rotating. So they all have tension, they all have m, you all have to find out the acceleration. All these questions are very similar from 33 to 38, 39, 40. They're all very similar to each other. Let's try to solve these questions. For some questions, I'll give you a detailed solution. For the rest of it, I suggest that you you take my suggestion from here, you see the video, you take the suggestion, you try it on paper, you can solve it. It's kind of easy. So question number 33. There is a block that is sliding on an inclined plane. So the mass of this block is equal to small m. There is a pulley attached over here. I'm pretty sure that pulley is going to have a mass because the pulley is going to rotate. And it is connected to a bigger mass. So this mass over here is capital M. This is a bigger mass. So one thing that is going to happen is this mass is going to come down, let us say with an acceleration of a. So this is going to go forward with an acceleration of a. One concept to clarify over here, some students ask me, because there is friction at the pulley, how come both of them have the same acceleration? Now they have the same acceleration. It is because the length of the string is fixed. Even if there is friction, if you pull one end of a string and the string can move, the other end of the string will also move by the same amount. That's because the length of the string cannot change. तुम अगर एक तरफ उसको 2 सेंटीमीटर खींचोगे तो वो दूसरा तरफ भी 2 सेंटीमीटर मूव करेगा. हाँ, फ्रिक्शन है तो स्लो मूव करेगा, लेकिन मूव उतना ही करेगा. So the acceleration on both ends of the string is going to be the same. It's going to be a for both of them. The moment of inertia over here is I, and let us say the radius यहाँ पे दिया हुआ है, the radius is equal to r. So this pulley over here, the small little pulley, is going to rotate with some angular acceleration alpha. So you obviously know a is equal to r alpha. A is equal to r into alpha. तुम्हारा इक्वेशन सीधा साधा. अब क्या करना है, इस पे सारे फोर्सेस ड्रॉ करके यू हैव टू स्टार्ट राइटिंग इक्वेशंस. तो यहाँ पे टेंशन कितना लग रहा है, टेंशन इज T1. यहाँ पे टेंशन कितना लगेगा, टेंशन इज T2. तो इनके फ्री बॉडी डायग्राम्स तुम ड्रॉ कर दो. तो दिस इज M, दिस इज गोइंग टू बी T1, दिस इज कैपिटल M ओवर हियर, सो दैट इज गोइंग टू बी T2. ठीक है, और यहाँ पे तुम्हारा पुली है, तो पुली का इस तरफ लाइक टुवर्ड्स द लेफ्ट द टेंशन इज T1, and towards the downward direction the tension is equal to T2. Keep in mind which is moving in what direction. This is moving in A in that direction, this is moving downwards with the acceleration of A, and the rotational motion of the pulley is in this direction. This is alpha. Obviously there is a weight of mg. Any forces that are not relevant to the motion of these blocks, I have not drawn them. So if a force is not relevant to the motion, I did not draw the force altogether. ठीक है, तो mg is acting in the downward direction, T2 is acting in the upward direction, and those are the forces. Right now, you should pause it, try this thing on your own. Try to draw an FBD on your own. Okay, तुम्हें FBD draw करना आना चाहिए. अब body by object by object तुम्हें बस इसके equations लिखने हैं. So for the first object over here, for the small m object, so you will write plus T1 is equal to ma, because the direction of T1 is matching the direction of A. Second, for this object, mg is matching the direction of A. So you will write plus mg minus T2 is equal to ma. And for the third one, T1 is opposite to the direction of motion, and T2 is in the same direction as the motion. Like this is T2 and that is the direction of motion. So T2 is in the same direction of motion. So you will write what? Plus R into T2. The radius of the pulley is R. The force is T2. So plus R T2 minus R T1 is equal to I into alpha. Is equal to I into alpha. Find the acceleration of the mass m. So we need to find out the value of A. हमें A का value चाहिए. So strategy is very simple. Alpha के जगह पर A का value लिखो. Alpha is equal to A by R. Use the value from here. You put it in alpha. In place of T1, you take the value of T1 and you put it in place of T1. You take the value of T2, you put it in place of T2. So you will write plus R. Instead of T2, you can write mg minus ma. Instead of T1, so this is R into T1, not R minus T1, that is R into T1. That dot was accidental. So into T1, T1 कितना हो जाएगा? That is equal to ma is equal to IA divided by R. Now you can remove R from the entire equation. You can remove R from here. You can remove R from there. You'll get IA by R square. Now mg is equal to ma goes to that side. Small ma also goes to that side. IA by R square is also on that side. So you can write A is equal to mg divided by m plus small m plus I by R square. Simple, it's not very hard. You can solve these questions. For those of you people trying to understand that what is really going on over here, यहाँ पे ऐसा हो रहा है कि this block over here, this mg block, it has a particular amount of weight. This block का एक particular amount of weight है. And what is the weight of the block? The weight of the block is mg. So because of it, this mass is rotating, this mass is moving, the other mass is moving, and the pulley is also rotating. So the weight of the block is doing three different things. It is moving the mass m, it is moving the mass small m, and it is also rotating the pulley with a moment of inertia phi. So the acceleration of this thing is going to be mg divided by whatever mass is moving. So mass that is moving is m, small m, and that pulley, the pulley is rotating. So you will write capital M plus small m plus I divided by r square. You obviously cannot do that directly. I just wanted you to understand or get a feel for what is happening in this question. The weight of the pulley is moving those three different things. That is how the acceleration is shared between all three of them. ठीक है, ये तुम्हारा क्वेश्चन नंबर 33 है. नाउ गो टू क्वेश्चन नंबर 34. अ स्ट्रिंग इज wrapped around a wheel. ठीक है, and it is passing through a light pulley. So what is a light pulley? A light pulley has no mass and no moment of inertia. So its rotation is not going to be used in the problem. You're not going to use the rotation of a light pulley in your problem. A string is wrapped around a wheel of moment of inertia 0.2 and radius 10, and it goes through a light pulley to support a block of mass 2 kgs. Find the acceleration of the block. तो तुम्हें ब्लॉक का acceleration निकालना है. तो कैसे करोगे? You have a pulley, and on this pulley, the string kind of looks horizontal tangential to the pulley. So this is your pulley. ठीक है? यहाँ पे the pulley has a radius of 10 centimeters approx. It is fixed in one place. Then this string passes over a very small pulley, which is not useful to us in this problem, and it goes down to a mass of m. So let us say the mass of this thing is m, which is given as 2 kgs. The moment of inertia is I, and the radius is r. This is the problem that we have. This small pulley over here is basically massless. So the rotation of this pulley does not matter. So this pulley is massless. So its rotation has absolutely no effect on the question. But this pulley has mass. So its angular acceleration is alpha. So if its angular acceleration is alpha, what about the acceleration of this thing? This is also going to have some angular acceleration, except we are not bothered what it is, and it is also not going to come in any equation, because if the pulley doesn't have mass, it is not going to have moment of inertia. And because it doesn't have moment of inertia, I into alpha is going to be 0 as I is equal to 0. So that's why I'm saying there is no effect on the equations. अब क्या करते हैं, equations लिखते हैं. So what is the tension in the rope? The tension in the rope is T. What is the tension in the rope over here? That is also T. So isn't there friction over there? Yes, there is. There is friction. But that pulley is massless. So the value of frictional force has to be 0. Because if at all there is any kind of friction, there will be an angular acceleration. And without a moment of inertia, the angular acceleration will be infinite. There will be a very high angular acceleration. So the practical way to talk about it is that because there is no weight of the pulley, the string is not going to rotate the pulley. It's just going to slide, like slide over it or move over it effortlessly. Not slide, move over it effortlessly. So there will be no change in tension. The tension is the same in both places. Let us say the linear acceleration is a. So you can write first of all a is equal to r alpha. Take it, first equation. Now what is the force acting on this block? That force is equal to mg. तो तुम यहाँ पे लिखोगे plus mg. बैकवर्ड डायरेक्शन में टेंशन लग रहा है तो तुम लिखोगे इज इक्वल टू एम ए. Over here, the tension force is tangential to the pulley, so you will write plus r into t. It is helping the acceleration, so you will write I into alpha. अब तुम्हें बस t को हटाना है, तो t is equal to I alpha divided by r. इसको ले जाओ and you put it in the first equation. तो you will get mg minus I into alpha मतलब a divided by r, तो ia by r square is equal to ma. तो a का जो वैल्यू आएगा a is equal to mg divided by m plus I divided by r square. So once again, you can understand this in exactly the same way. You can say that the weight of this pulley, this weight, is doing two things. It's moving this block and it is also rotating the pulley. So that is why it is getting shared. तो वो बात सही है. Now at the last step, you can always put in the values that are given to you. It says that the moment of inertia is 0.2. The I is equal to 0.2. So instead of I, you can write down the value of I, which is equal to 0.2 kg meter square. What is the radius of the pulley? The radius of the pulley is equal to 10 centimeters to 0.1 squared, plus what is the mass? The mass of the block is equal to 2 kgs, that is 2, and gravity is 10. So 20 हो जाएगा. So 20 divided by 2 plus 0.2 divided by 0.1, which is equal to 2, divided by 0.1, which is equal to 20. So it is equal to 20 divided by 22, which is equal to 10 by 11, which is approximately equal to 0.9. So the acceleration of the block is equal to 0.9 meter per second square, approximately. So exactly, I think it will be 0.909, something like that, 0.91. So approximately it is 0.9 meter per second square. समझ में आ रहा है प्रॉब्लम्स कैसे कर रहे हैं एफबीटी बनाओ फोर्सेस को लिखो एक्सेलरेशन को लिखो a is equal to r alpha लिखो and then just try to solve the problem. We'll solve a few more, बाकी तुम लोग ट्राई करना. Question number 36. 35 में क्या बोल रहा है? Suppose the other pulley also has a moment of inertia. So this is a good thing. You need to think about it and you need to solve 35 on your own. Suppose there is a moment of inertia of the other pulley. तो ये जो पुली अपने पास है, the second pulley that we have, अगर इसके पास moment of inertia, तो what is the one change that will happen? The change that will happen is the tension on both sides of this pulley is going to be different. So this is going to be equal to T2 and that is going to be equal to T1. अब इसका भी तुम alpha निकालोगे. So you'll also have to find out an alpha over here. So the radius of that thing is 5 and the radius of this thing is 10. तो अगर इसका alpha होगा तो इसका alpha 2 alpha हो जाएगा. So you just take my word for it. So you take 35 and you draw the question like this, that there are two pulleys in that question. So there is a big pulley, there is a small pulley. The big pulley has an angular acceleration of alpha. The small pulley has an angular acceleration of 2 alpha. Now there is a block hanging from this thing. The block has a mass of m. It's moving with a speed of a. It's moving with an acceleration of a. The tension in this rope is T2. The tension in this rope is T1. And then you solve the problem. You find out the value of a and you find out the value of T1, T2. It's asking you what is the tension in the string joining the pulleys. So it's asking you what is the value of T2. तो तुम्हें वो solve करके निकालना पड़ेगा. So take this thing, take my word for it. This is alpha and that is 2 alpha. ठीक है और इसको सॉल्व करना बताना if you are able to solve it. Question number 36. The pulley in the figure are identical. The pulleys in the figure are identical. Each of them has a radius of r, a moment of inertia of I, और तुम्हें ब्लॉक का एक्सेलरेशन निकालना है. There are two pulleys in the problem. There's one pulley over here. There's another pulley over there. ठीक है, there are two pulleys in the problem. और इनके masses हैं capital M और small m. So this is small m. This is capital M. So these are their masses and there are two pulleys in this thing. ठीक है, अब क्या करना है तुम्हें इमेजिन करना है what is going to happen. So this is going to move down, that is going to move up. What is the tension over here? So let us say the tension over here is T1. What is the tension over here? T2. What is the tension over here? T3. Why? Because both of these pulleys have some amount of mass, some amount of moment of inertia. So the friction is going to change the tension in the rope. So T का value अलग अलग रहेगा. It is going to be T1, it is going to be T2. There are going to be two different values of tension. T1 और T2 करके दो अलग अलग values होंगे tension के. तो अब तुम्हें क्या करना है इसका इक्वेशन लिखना है. सो दिस इज गोइंग टू रोटेट विद सम एंगुलर एक्सेलरेशन अल्फा, दैट इज आल्सो गोइंग टू रोटेट विद द सेम एंगुलर एक्सेलरेशन अल्फा. व्हाई इज द एंगुलर एक्सेलरेशन सेम? बिकॉज द साइज इज द सेम. अगर साइज कम हो जाता तो एंगुलर एक्सेलरेशन बढ़ जाता, बिकॉज ए इज इक्वल टू आर अल्फा. ए इज द सेम फॉर ऑल ऑफ देम. सो इफ यू टेक अ बिग पुली द एंगुलर एक्सेलरेशन इज अल्फा. So if you take a smaller pulley, अगर तुम पुली का साइज छोटा कर दोगे, like in the last problem it became 5 centimeters, this is going to become 2 alpha because the product has to be the same. So if you take the same pulley again, that is again going to be alpha. So that is why in the previous problem I said take one of them as alpha, take the other one as 2 alpha. So ये reason था उसके पीछे. So now this is alpha. तो अब इसका तुम equation लिखोगे like you very well know how to write. यहाँ पे तुम इसका weight लगा दो mg, यहाँ पे भी तुम इसका weight लगा दो mg. I'm not drawing a separate FBD. When you do it on paper, you draw a separate FBD. So you'll write plus T1 minus mg is equal to ma. First equation, plus T1 minus mg is equal to ma. For that pulley, you notice what is happening. T2 is supporting, so you'll write plus RT2. See, T2 is supporting. But T1 is going to act on the pulley in the downward direction. So T1 is opposing that motion. So you'll write minus RT1 is equal to I into alpha. Okay, that's it. And then finally, for the second pulley, you will write what? T3 is supporting and T2 is opposing on this pulley. So इस पे T3 ऐसे लग रहा है and T2 ऐसे लग रहा है. तो T2 is opposing, T3 is supporting. तो plus R T3 minus R T2 is equal to again I into alpha. Again I into alpha. ठीक है? So that's the equation for that one. Last वाले में equation क्या होगा? The final one, the one over here, you will write plus mg minus T3 is equal to m into A. These are your four equations. Obviously, you can divide these equations by R first of all. So if you divide it by R, you'll get I alpha by R, I alpha by R. You can again replace alpha with A. So you will get IA divided by R square, IA divided by R square. अब इन सारे equations को तुम add कर दो. So if you add all these equations, T3 is cancelling out, T2 is cancelling out, T1 is cancelling out. So you'll get mg minus mg. है ना? Why is the system moving? Because there is a difference of weight. So the difference in weight is moving the system. So what all is it moving? It is moving m. It is moving two pulleys, so 2I by r square. It is also moving small m. So the acceleration of the system is equal to g into m minus m. The difference in weight divided by m plus small m plus 2I divided by r square. तो ऐसे तुम्हारा चीज सॉल्व करते हैं. This is how you write down the equations and you try to solve it. So I hope you understood. I can keep solving these problems with you. Well, just like get exhausted. So एक चीज करते हैं. I'm going to stop over here. I'll leave you with a few other questions to solve. There is question number 35 जो तुम्हें खुद से try करना है. There is question number 37 जो तुम्हें खुद से try करना है. There is 38 जो तुम solve कर सकते हो. Try it on your own. Left वाले पेज पे तो you can solve almost everything. On page number 196 you can solve literally everything on page number 196. All of it on 196 you can solve. There is a question with variable moment of inertia like question number 15. वो भी तुम कर सकते हो. There is one thing I did not talk about so far, so I'll add a theory part to the last thing in this chapter. There is something that is called as radius of gyration. Radius of gyration. Gyration is the fancy word for rotation. What does gyration mean? Gyration just means rotation. So radius of gyration is actually a mathematical concept. It says that the radius of gyration for an object is the distance at which it is the distance at which it is the distance at which if a point mass, if a point object of the same mass is placed, point object of the same mass is placed, then it is the distance from the axis, by the way, from the axis of rotation. It is the distance from the axis of rotation from which, if a point object of the same mass is placed, then its moment of inertia will be the same as the object. Its moment of inertia will be the same as the object. This is the reason I don't try to write definitions or tell you, because it's very roundabout. I'll explain moment of inertia kya hota hai. The moment of inertia, the radius of gyration is represented as k. So if you write mk square, then you can equate it to some moment of inertia I. So k is equal to root over I by m. It's very easy. It's not that complicated. Let's take a disk half mr square. So what is the radius of gyration? Just write mk square. Cancel out the m. K is equal to r by root 2. Simple. Take a disk or take a sphere. So 2 by 5 mr square. What is the radius of gyration? Equate it to mk square. Remove the m. K is equal to root over 2 by 5 into r. ठीक है, तो ऐसे हम लोग रेडियस ऑफ गायरेशन निकालते हैं. Why is radius of gyration used? Radius of gyration is used mostly in mechanical engineering when you are trying to design something. If things have a very small radius of gyration for the same mass, if the radius of gyration is small, then the moment of inertia is also small. They're easier to rotate. So all of these wheelchairs on which you sit and you rotate around the wheelchair, they're very easy to rotate. They have a very small radius of gyration. Even ceiling fans have a very small radius of gyration. They're easier to rotate. But doors, windows, like normal doors and windows, we don't bother. But places where doors are important, like in safes and all that thing. So doors are designed in such a way, or even in the doors on the boundary wall of your plot or a building, they are designed or fabricated in such a way that the moment of inertia is there is a certain moment of inertia. If the moment of inertia is very high, the door will be very hard to open. And if the moment of inertia is very, very small, the radius of gyration is very small. If you push the door a little bit, it will swing open, hit the boundary wall, and come back and hit your face. You don't want that. So that is why the radius of gyration is used in designing things. Okay. See you in the next class. Try to practice problems from HCD.